Hey, I'm Mr. Sarkany. I'll be helping you out this year. We're going to look at making some good simple measurements. So, there's digital instruments, non-digital instruments. We'll be looking at volume and temperature, a thing called uncertainty, and how to read temperature and volume well. So, some examples of digital instruments. We've got an electronic balance, temperature probe, pH probe. Anything that's what's called a probe would generally have a digital readout. Now, something they all have in common is they tell you exactly what the measurement is. These are the simplest. These are the easiest. There's no need to interpret it. You just write down what the instrument says. Non-digital instruments are a little different. These are the old things. They call analog. You've got graduated cylinders, thermometer, pressure meters. I don't think you use in middle school triple beam balances. We won't use those here. But anything that measures volume is definitely an analog device, or non-digital. Now what these have in common is they need you the human, to actually make the interpretation of the instrument. You can't just look at it and know. You need to know little rules and a little application, and we'll get you there good. Now I mentioned this thing called uncertainty. Not sure what it is? Of course not. That's what I'm here to tell you. So uncertainty is the amount of any measurement that it may be off by, plus or minus value. So every measurement has a plus or minus value. So when do you write it? Every time you have a measurement, digital or non-digital. How do I know how much it is? Well, for digital instruments, it's whatever the manufacturer would say, or plus or minus the smallest increment. So if we go back a little bit, and we have our temperature probe, 26.3 degrees Celsius, that means the smallest increment is 0.1 degrees Celsius, so therefore we would have it as plus or minus 0.1 degrees Celsius. For non-digital instruments, it's plus or minus half of the smallest increment of measurement. So plus or minus 1/2 of whatever the smallest increment is. Let's take a look at a few examples. Oh yeah, we are. So for volume, we need to look at what we have for each of these. So how much is each of the smallest lines? So I see it goes from 10 to 20 with 10 lines. So each small line is 1 milliliter. What can I see for sure? Well, I can see it's at least 18, so that's what I'd know for sure. Make an estimate for one more decimal place. It looks a little over, so let's call it 18.1. Now the uncertainty is 1/2 of the smallest increment. The smallest increment is 1 milliliter, so half of that would be 0.5 milliliters. So our total measurement, 18.1 milliliters plus or minus 0.5 milliliters. Now let's look at temperature. So we've got a thermometer here, again analog. So how much is each small line? Each small line appears to be 1 degree Celsius, because 10 to 20 and 10 lines. What can be seen for sure? Well, it definitely looks like it's over 21, 22. So 22 for sure. Make an estimate for the one decimal place. It looks a little over. I'm going to say 0.3 Celsius. That's my interpretation. So 22.3 Celsius. Now the uncertainty is not going to be in milliliters. That'll be degrees Celsius. And so the uncertainty for that one is going to be 1/2 degrees Celsius. So my measurement, 22.3 degrees Celsius plus or minus 0.5 degrees Celsius. That will enable anyone who estimates this value, as long as they do it accurately, doesn't just say it's 47, the fact that they're going to be within that range due to their estimation. Now down to some final thoughts. At the end we'll always have a joke. So, what did the thermometer say to the graduated cylinder when they were trying to determine who was smarter? You may have graduated, but I have many degrees. Please answer that final question on your paper and come in with any questions you may have. Hope to catch you. See you soon.